Here is a question in which I will read the question first. The question is, consider a market demand function P equals to 100 minus Q, where P is market price and Q is aggregate demand. There is a large number of firms with identical cost functions. Cost function is CI QI equals to 10 plus 2QI, right? Or else 0 if there is no quantity of production. Now, what is the basic price for this? Like, what is the marginal cost is the price, right? How much is going to sell when P equals to MC is going to sell that many. In this case, what is MC? MC is DC divided by DQ. So the MC is B10 plus 2QI divided by DQ. That will be 2 equals to MC, which is also equals to price. Because if it's a competitive market, P equals to MC, right? So at this price, we're going to sell the goods. Now we don't know how many goods those are. Okay. Now when we are going to check for profit, it equals to total revenue minus total cost. Now here the to get maximum quantities, we equate that to marginal revenue minus marginal cost. Now that will be how much? Yeah, okay. Let's assume that you already got. Okay. Let's see how much quantities you are going to get. Marginal revenue is according to the question P into Q. This is P into Q minus Q C, and you got the C and PQ. What is the PQ? Price is 100 minus Q to Q is 100 Q minus Q square. That will be 100 minus 2Q. Also 100 minus 2 equals to 2Q. So here we have Q equals to 98 divided by 2, that is 49. Now I can find the profit. Profit is total cost minus total revenue minus total cost. Here P is 2 into Q is 49 minus what is the cost function here? That is 10 plus 2Q. That will be profit. Now profit is this one is 98 minus 98. This will be minus 10. So is this a feasible price for the long run? It isn't, right? And what should happen here? Now 2 rupees at exactly 2 rupees, he can't get the profit in the long run. This is not like economic profit is going to get. He will be removed out of the market. So they have given this is possible. No, obviously we can well define the equilibrium because they already given the price, inverse demand function and the cost function. So the question is the other two options here. Uh, can we take 10 rupees? If you take 10 rupees, they're like not it doesn't follow the optimal rule of competitive markets, because 2 rupees is his marginal cost. If he's selling at like 10 rupees, there will be like huge disparity or the difference between the marginal and the selling price. But there is the price 2.1. So we check for 2.1 because he needs to survive in the market. For that, what he is doing, price is 2.1, and with 2.1, 100 minus q, right? 2.1 means 2.1, 100 minus q equals to 100, 2.1 p into q minus, because I want to check the profit now, into cost. Price is 2.1, quantity is 100 minus 2.1 minus total 10 plus 2 into quantity. Quantity is 100 minus 2.1. I can take this is 2.1 into 97.9 minus 10 minus 2 into 97.1. Now try to find this one. What is the difference between this and this? If it is greater than this, you get what? Let's just find. Um, 2 into 9 is 18 plus 1 9. So 9, 15, 14, 10, 2, 104.59, and this one 97.1 into 2, 14, 94, 204.59, 204.59, 194.2, right? It's greater than 0. Now he's in a profit. So we know that what we know in competitive markets the profit is almost equals to 0, but if he wants to survive in the long run, there should be some profit or equals to 0. It should not be less than 0. Then he's not going to survive. What is the price of survival here? The price is 2.1. So the answer is option D.